dynamical system framework. In this video, we'll see an example model with disturbance. Let us consider the car model with the disturbance criteria. Now instead of a normal road, we have a graded road. Let us see how to model this graded road car. Now the road is graded and it is making an angle theta with the horizontal axis. This car is trying to move in this direction, uphill direction, and it is receiving an input force F. So we have already seen in the last video. Now whenever we have an input force, there will be having an opposite force because of friction. That is in opposite direction. The value of that friction is equal to that K into V, where K is a friction coefficient and V is the velocity of motion of the car. And now this car, because of the force F, is moving in this direction with position X and velocity V. And the weight of the car is equal to m into g, where m is mass and g is the gravitational acceleration. So now we can model this car as a component with two inputs. Earlier we have seen a car with only single input called F. Now when we have a disturbance along with our input, this can be controlled and this cannot be controlled. So we have two inputs. One is called as actual input F, other one is called as disturbance theta. For this case, the theta is the angle that the car is making with the horizontal axis, and we have the output velocity V. Now we have two state variables. One is called X, other one is called as V. As usual, X is having its lower and upper limit XL and XU, and V is having its lower and upper limit VL and VV. Now based upon the current value of X and V, we have to calculate the next value of F and V, that is X dot and V dot. And as seen in the last session, our X dot is equal to V, that is rate of change of distance is equal to velocity V, and V dot is equal to, last class we have seen like F minus kV by M. Now instead of this component, we have additional component whose value is equal to minus mg into sine theta, where theta is the angle that the road is making with the horizontal axis, and m is the mass of the car, and g is the gravitational acceleration. Now the equation for V dot has been changed from F minus kV to new value called F minus kV minus mg sin theta. This component corresponds to the disturbance component present for the input. So as we have mentioned earlier, instead of the normal input F, we have additional input called theta, that is called as disturbance, and this theta is the angle that the road is making with the horizontal axis, and a positive value of theta denotes that the road is uphill and a slope is positive. Negative angle represents that the slope is downhill, that is slope is negative slope. We have seen the weight of the car, that is equal to m into g, in the downward direction, where g is the gravitational acceleration whose value is equal to 9.8 meters per second square. So we have a force that is acting on the car in the direction along the road R, F, that is the input force, that is applied force in the forward direction that can be controlled by the engine. Second one is K into V, that is in the opposite direction. This models the friction coefficient K, and velocity V represents the friction that exists in the car, and mg into sine theta, this represents the gravitational force along the road. So we have an input force, we have a frictional force that is opposite to the input force, and this is the gravitational force along the road that is also opposite to the input force. Because of this only we have F minus kV minus mg sine theta in our equation. Now we'll see have to compose a component by using basic building blocks. When we want to form a large component, we have to integrate many small components in order to complete the task. So just like continuous time components can also be composed by using block diagram, just like the way we have done by using synchronous components. We can combine two or more components to form a large component. So what are the way operations that we can do on those components? Is we can do variable renaming, and we can do output hiding, and we can do parallel composition. So whenever we are combining components, we have to rename them for clarity, and then whether we want to hide the intermediate outputs, we can hide it, and we can have only the final output, else we can go for parallel composition of outputs. So while doing so, we have to ensure that we are avoiding the cyclic dependencies, because even a single component if has cyclic dependency, then the final component, composed component, will also have cyclic dependency. So we have to design a component that should avoid any cyclic dependencies. So in this video we have seen a model with the disturbance, and we have seen how to compose component. The next video we'll see different types of stability that we are going to deal about continuous time systems. Thank you all.